Hello everyone, we are Group 4, and for our semester project, we explored how game data can be reverse engineered and manipulated at the binary level using Pokemon Platinum, which is a Nintendo DS game, as our case study. Instead of modifying the game source code, which would be a completely different project altogether, we focus on just the save file, which is a structured binary format that stores all the player and Pokemon data. By analyzing the structure, we identified how individual Pokemon are represented in memory, including attributes like species, experience, moves, stats, with a plethora of other things. We then use custom scripts to decrypt these data blocks, modify specific fields directly in hex, and recompute the checksum so the game would accept the modified data. This allowed us to precisely control in-game behavior such as changing a Pokemon species and name purely by editing data without altering the game's logic. Our project highlights how understanding data structures and memory layout can just be as powerful as modifying source code, and emphasizes the role of data integrity mechanisms in software systems. We'll now walk you through a live demonstration of how this all works. Alright, I've got two folders on my desktop, one of which contains 3 script files, a checksum, an encryption, and a decryption file. And then now I'm going to load up Melon DS, which is the emulator for the ROM, which is the top file there on my desktop, and the game will load. I sped this up just for the sake of time because the game kind of takes forever in some of these parts. But first thing I'm going to do here is save the game. And as you can see, it's saving, and then I swipe back over and you see a save file is generated and is placed on my desktop. And now I just opened it up with like a text editor, and you can just see it's just garbage values. But now in the other folder we have our hex editor, which I open it up and I drag that file into it. Now with the help of another website that we use that gave us the offsets of some of these memory locations, we learned that the 40,000 offset is the first active block in the save file. So that's the first thing where there's any viable information on it, and we know that that A0 offset is the first party Pokemon location in that save file. So now I bounce back to VS Code, and what I'm going to do here is I'm in the decrypt script here, I'm going to copy over that hex, and I'm going to paste that hex in and run the file. And when I do that, you can see I get an error because there's nothing there because I don't have any Pokemon yet. So that specific offset and that block is not working right now because it's empty. So right now I've sped it up a little bit because this kind of takes forever. They're just kind of talking here, and then he meets the professor who's going to give him his first Pokemon, and then you pick your Pokemon, and then your friend wants to battle, you battle, and then once the battle's over, now you have your first Pokemon. So you finish talking and you spawn back at home, and then you go and check, and now you have your first Pokemon. You see here Turtlewig and all of his stats here. And then now I'm going to resave the game again. So now when I resave the game, that memory block with that first party Pokemon is not going to be empty once we decrypt it. So I'm going to navigate back down to the A0 offset, highlight that entire block for that first Pokemon there, and I'll show you later the website where we got all this information from. But now I'm gonna take that, paste it into our script here, and run the file again. And what you can see here that printed out at the bottom is the actual decrypted hex. Now this is the actual website where it gives you all of the offsets for a lot of the characters, a lot of all the mappings in the game, moves, upgrades, you name it. There's a plethora of things you can do with this, but you can see the structure of the save file here. So this is where we kind of got our guidance from of where to look in the save file, because other than that, it's like a needle in the haystack. So now I went back and I pasted the decrypted hex back into the hex editor, and I'm now editing here. So this specific bit changed the Pokemon species, so I just changed them to Pikachu. And those 4 bits right there are the experience level for the character. So now he's Pikachu, and I made his experience level like ridiculously high. And then here is the name of the letters, the actual letters for the character. So these bits here all represent the letters of the name. So as you can see, I highlight here Pikachu, P-I-K-A-C-H-U, with the double F as the null terminator at the end. So before it was Turtlewig, and now I just changed that to Pikachu. And now I'm going to take that entire block, copy it, go back to VS Code, go to the encrypt file now, paste that in there, then I'm going to run the encrypt file. And now it's re-encrypted everything. And now I go back and I paste in the re-encrypted bits into that block. But now to get this all to work perfectly, now we save the file. As you can see, it saves the file back to the desktop. And then I go and I drag that file into the folder with the checksum file, because it has to be in the same folder as checksum. And so here we are in the checksum, and the checksum is basically just a digital fingerprint to make sure nothing's been changed. So we're going to run it against the same algorithm as used to make it. And when we do that, it prints out this fixed.save file, but the fixed.save file has to be saved to that exact name of the original file. So I swapped names, and then I put the original file back on the desktop. I relaunch the emulator, I redrag in the ROM, and it should, if everything goes correctly, recognize the saved file, and he should be spawned at the same spot and everything. So we open it up, he's right back where he was, and then I'm going to check my bag, and boom, you got little Pikachu bouncing around there, and you can see here he's nice and happy. His name is Pikachu. I changed it. I could have kept it as Turtlewig, and you can see his experience level is off the charts there at 970,000 or whatever. It's really high. So basically, this is just a really quick demo just to show like what you can do with this. We also edited the moves list. Only thing is you have to have a Pokemon in the slot to edit it, so it can't just be an empty slot. But if you have a Pokemon there, you can go in, reverse engineer it, and tweak the bits and do whatever you want. Basically change the name, change the character. You can even change the sprite so that it's all kind of wonky, but you can make your guys stronger and everything. So it's pretty cool. So that's it for our presentation. Hope you guys liked it. Didn't want to make it too crazy long, but yeah, if you guys have any questions, let us know. And again, thanks for listening.